For our first question, we have 200 pupils taking this mathematics test, and their scores are normally distributed with a mean of 50, standard deviation of 10. Okay, so this is a sign that we are going to use normal distribution to solve the question. Okay, so in part A, we have pupils who obtain 70 marks and above will be considered as excellent. So we need to find the number of pupils within this range. Okay, but before we solve any kind of question, let's set our point of view or the thing we need to focus on, or meaning determining our x. So going back to the question, it says that the scores of the mathematics test is normally distributed. So for our x, we can say that score of the mathematics test. So to find the number of pupils, we have an issue, which is from the 200 pupils here, we are not sure what is the percentage of students that can get 70 marks and above. Right? So what we need to have to find the percentage is to find the probability first. Okay, probability meaning the chances that a pupil can get 70 marks and above. Okay, so we need to focus on that probability. So to find probability using normal distribution, we will be using the 5S method. Okay, so the first S is statement. We need to figure out what is the probability that we're trying to find. So here, if using x, we are trying to find the probability that x will be more than 70 marks and above. Okay, here we will be greater than or equal to 70. Right? Then the second S would be search. We need to search the two parameters, which is our mean, which is 50, and standard deviation, which is 10. Okay, third step, standardize. So standardize meaning from the x here, we are changing to z using this formula. So for each of the x here, for each of the scores, we are minusing the mean divided by the standard deviation. Okay, something like this. Then we are going to simplify. And the fourth S would be sketch. Sketch using the normal distribution graph from this statement. Okay, so here our center line is 0. Okay, because we have already standardized our graph, so mean or the center line would be 0. So if we put 2 to the graph here, it will be somewhere here. So since this is greater than or equal to, it's like giving this arrow sign. So from 2, we are going to sketch to the right side. Okay, so this is how we sketch the graph. Then the fifth step is to select the correct probability from the table that we are going to see later. So before we go to there, we need to make sure the graph satisfies the two conditions. One is one side. Okay, so our area is one side, correct, and from the right, which is correct also, because this area comes from the right side. Okay, so this area satisfies our condition. So now we can go to the tables to find the probability. So our Z is 2.000. So for the first step to find probability is match the first 4 digits. So the first 2 digits, we are going to look at section A. So 2.0 is here, and we're going to focus on this row. The third digit is 0, so according to section B, 0 is here, so the column that we're going to focus on is this row, this column. Okay, so here our probability would be 0.0228. Okay, then the second step is minus, but this one we can skip because the fourth digit is 0, where in section C you cannot see 0. Okay, so if it's 0, we can just ignore. So once we have the probability already, then we can change it to percentage form and multiply with 200 to get the number of excellent pupils. So if you see here, I didn't change to percentage form. So if you remain its decimal form, it's fine as well. Okay, if you want to change it to the percentage form, which is 2.28%, is also fine. Okay, so two answers are accepted. So once you multiply already, you realize that your answer is 4.56. So should we write 4 or should we write 5? So if you separate the 4 from the decimal here, So we have 0.56, and if we understand 0.56, 0.56 pupils is actually half of a pupil, which technically also means it's not a pupil, not a person, because it's just half. So this one, I would change it to 0. So the answer would be 4. 4 pupils with the excellent mark. For the next part, we have 60% of pupils pass the test, so we need to find the minimum score to pass, or the passing score. Right? So to understand this question, let's view it from the normal distribution graph, where this line, the x-axis, is the scores of the mathematics test. So meaning, students with low scores would be somewhere here, students with high scores will be somewhere here. So now, the minimum score to pass, I need to decide whether it's here, 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 or somewhere else, which I don't know yet. So the way to determine this is to sketch the 60% first from this graph. So now we are trying to sketch the area where it covers 60% of this graph. Okay, so to start sketching, I would choose from the right side, because these are the students where they will have a higher mark, so confirm they will pass the test. Okay, so later on I will sketch from the right side. And another thing is, if I split this graph by half, right, here all the way to the right side is 50%, here all the way to the left side is 50%. So when I sketch from the right side, I need to exceed this line a bit, because it's 60%. Alright, so the way I would sketch the graph would be something like this. Right, so I will exceed a bit, and this orange part would be 60% of the total graph. So the minimum score, it will be somewhere this line, and I'll denote it as x first. So now we need to find the x, which is our passing score. So even though we are not finding the probability, we are trying to find the value of x for this question, but it's okay to use the 5S method, because both questions involve the graph. Right? So for our first S, which is the statement, so we can write out the probability statement from this graph. So there are two things we need to note. The first thing is, for the scores which is inside the shaded area, which is here, all of these values must be more than x. Alright, more than x. And the second thing is, the percentage is 60%, right? The sketched part is 60%. So we need to add more than and 60% inside our statement. So we can say that the probability that our score must be more than x, and the probability must be 60%, or 0.60. Why I put equal sign here is because, let's say your passing score is 40 and you get 40, so you should be considered as pass, right? Which is why I put equal sign here. Then our second S is search. So in part A, we have already searched that the mean is 50, standard deviation is 10. Third S is to standardize, so from x to become z, so for both x here, we need to minus mu divided by sigma. And then here, we simplify this part to become z. Fourth S is to sketch the graph, which we have already done, so now I just change some things a bit. So since we standardize from x to z already, so our mean has become 0, which is why mean will be here, and that's why here there will be the y-axis. Okay, and then since we have changed from x to become this value, so for the x here, we'll change it to x minus 50 over 10. And our fifth S is to select the z value from the table. Okay, but before we use the table, we need to satisfy the two criteria. So the area must be from one side and must be from the right. But here, if you notice, we fail this criteria, one side. The area has both sides. So our end goal here is to find out an area which is from here and must be one side only. So our z value here must be here. So how do we adjust our graph to become this graph? So instead of focusing on the big area, why not we focus on the small area? Because if I focus on the small area, we actually satisfy the first condition, which is the area must be from one side. But then another issue comes up, which is it's not from the right side. Okay, so what we can do is we move this part to the other side of the graph. Okay, we can move it because this graph is symmetric, meaning if I split this graph by half, left and right have the same shape. Same shape meaning same area. Alright, so we can move the left side area to the right side. But the only thing we need to do is the z value we need to change from negative to positive. Okay, so this will be a bit opposite A. Why we add -1? Okay, because this value is already negative. Okay, so if I add a negative to the number, it would become positive. Okay, so now we just focus on this graph, which both of the criteria has satisfied, one side and from the right. So now before we go to tables, let's write out a statement first. So now the probability would be z must be more than this number. Okay, and then the area here, so area we have already changed because the orange area is 60%, so the green area is 1 minus 60%, which is 40% or 0.4. Okay, so now this graph has satisfied. Now let's go to the tables to find the value of z. So our probability is 0.4. We need to find the value of z. So the first step is to find the first value which is larger than 0.4. So the first value which is more than 0.4 is this value. Okay, 0.4013. So we'll put it here. Then the second step is to find the differences. So these two, if I minus together, the value is 13. Okay, so from the same row, let's look at whether there is 13 or not. Alright, there is no 13. So if that's the case, let's find the number which is closest to 13, which is 12. Okay, so we just put it here. So if we minus these two values together, it almost matches our probability. Alright, so now let's go to section A, B, and C, find the 4 digits. Okay, so the 4 digits would be from section A is 0.2, section B is 5, section C is 3. So the value of z is 0.253. So we can say that according to the tables, the probability where z is greater than or equal to 0.253 would be the same as the probability that we want. So from these two statements, we can compare the z values to find the value of x. So once we find the value of x, it will be 47.47, but here it's a score. X is actually a score, which is need to be an integer. Okay, so we need to round it up to become 47.